Okay, I'm not sure exactly how to present what I'm going to do here. It's sort of like a public service announcement, and it's also a video for someone in particular. I started watching a channel in the Philippines called 62 to Freedom, and this fellow's building a house with, so far, poured concrete on some of it. But I see a problem he may be having, and I just want to address it because other people could have the same problem. He's on Panay Island, and there's a perimeter road just like most of the Philippine Islands. And the buildable part of his lot is about 20 feet down below the pavement of that road. And the road runs right up to a guardrail, just right at the top where it breaks from the road down. You have to have some way to get rid of your sewage in your house. So, the common thing is a septic tank. Well, most septic tanks in the Philippines are holding tanks. They intend to pump them out as soon as they get full. So all they do is they fill up and they pump them out. I don't see where he has access to get a pump truck anywhere near that part that he's going to build on, to pump it out. The house is the closest to the road, but you're not allowed to put a septic tank under your house or your carport either, by the way. So, next question is, what do you do? Well, you stop thinking holding tank and you start thinking a septic system. And it's going to process the waste into nearly drinkable water and carbon dioxide gas, which blows away in the wind. Second item. In the Philippines, as I've been told, and as far as I know is true, you're not allowed to have a leach field on your holding tank because you would be contaminating all your neighbors since everybody builds right up to the property line. But in any event, you're not allowed to have a leach field on a septic tank. Well, we have a couple hectare lot, so if it wasn't illegal, we would probably have a leach field. But we're not, because we're going to try to follow the laws. We're guests in this country. We're not going to teach them how to build a septic tank. So how do you do it? First thing is you have to have a digester that works. You want to put your raw sewage in, and aerobic bacteria will consume, the biggest part of it, other than bone fragments and sand. They go to the bottom. And they stay on the bottom. 20 years down the road, you'll have to dig them out. But everything else, it pretty much goes away. Now, this makes scum on the top and sludge on the bottom. So what you have to do is get rid of some of that also. So you need anaerobic bacteria. And you get this from the people that sell pellets to clean out your septic tank. You put them in 4 times a year. The bacteria lives and thrives as long as there's something for it to eat. And once it finishes up all the anaerobic waste, then it just dies. So you have to replace it once in a while. It's not naturally occurring, at least not in groundwater or whatever. So first thing we're going to address is the leach field. What we did was we dug our hole with the backhoe while we were doing some other stuff. So the hole was pretty darn big. We just had them scoop out a big hole with somewhere near flat in the bottom, and then we flattened it off. Just shovels and concrete sacks to carry dirt in. Spent about 3 days on flattening it off. Next thing we did, we put 25 centimeters of 3/4 gravel in the entire bottom of the hole. The hole is half again as big as a septic tank. But we covered the whole bottom with gravel. Now, we had polyethylene plastic that we brought to put on the concrete floors and stuff. So we put a layer of that down so that when we poured concrete, the cement paste and water wouldn't get into the rock. Just like it does if you pour a floor. If you don't put any plastic down, half your strength goes right into the rock. And I don't think people understand that, but they keep doing it. Okay. So we've covered this whole bottom with 25 centimeters of gravel. Next thing we did, we put a bucket down in the gravel. It's over here on this this corner right here. I don't know if you can see my thing moving. Top right hand corner of the tank. I'm wiggling over here. I can make that into a pointer. There you go. Yeah, that shows better. Okay, the bucket's over in here. And there's a polyethylene cover on the top of the bucket as well. Now, so we pour a floor. Just because we do a lot of overkill on this project, we poured that floor like 8 inches thick. It needs to be at least 6. But if you pour a thin floor, you need to put a perimeter footer around there, make it a monolithic pour, support the weight of the walls. So rather than get involved with that complex digging and more complex rebar design where we'd actually have to design the rebar, we just put them at 7 3/4 inches on center, number 16, and poured us a slab, the whole shape of the hole. Now, then comes the interesting, more interesting. If anything on this is interesting, this is next. We come in here and 42.6395 is what it comes out to, because we were measuring other things, and that was what was left. So it's 3.5 feet across a tank that's 96. It's 8'3" inside by 3.5 feet. Made a rectangle. This wall that divides it from the perimeter of the tank is 9 inches short of touching the roof or the bottom of the slab above the septic tank. That's for air circulation. Septic tanks require air for the aerobic part of the process. A lot of air. If you don't have air, your septic tank will smell. It will smell like a sewer, because that's what you've got then. You're not digesting anything, you're just transporting it. Okay, second wall. This wall goes, I think it's 60% of the width of the thing or something like that. Doesn't make any difference, just as long as you put a wall. If it looks good to you, that's probably fine. There's no rocket science in this part of it. So this wall goes from that cross divide wall to the end of the tank. This wall is taller. It goes up to where the roof slab will sit on top of it. It's not for structure. It's because we want to seal the air. We have in the ends of this tank, they're not showing in this, but there's like 5 pieces of 6-inch pipe that were set between the forms. Each end. The air's blowing from one end. It'll come in here and go out. And the other side, of course, has holes. It goes out. That replaces the air above your digester. If it's coming the other way, it does the same thing. If it comes at an angle, it can circulate and make it a loop around here, like a C shape, and back out. But the whole idea is that you have to make sure that you can flush all the air out of the thing. Never get rid of this cold. Okay, then that brings us to the final wall. This wall was I don't know how the whole width came out. This is a form that we use for the concrete columns for the house. For the 20 columns, we'd only used it 20 times, so it's in pretty good shape. And what we did, we made it where that would fit right between the other 2 concrete walls, which were poured first. This one, the top of this wall is like 2 inches below the bottom of the entry of the black water over here, which comes from these holes down in here. Goes in here through those into the second digester, back through holes into the third digester, and it overflows like a waterfall on this up here. So this wall determines the height of the liquid that stays in the tank. So that's a pretty critical number. It's like 11 inches down from the roof, and this wall was 9 inches. There's no perforations in this wall. It has to overflow it. The rest of these transfer ports, that are within the tank, they're halfway on the fluid level between the bottom of the tank and the top surface of the water. That way, your scum stays on the bottom, or on the top, some days on the top, and your sludge stays on the bottom. And what comes through here is liquid with a bunch of dander and stuff in it that needs the anaerobic bacteria to dissolve it. But it has to come through these transfer ports. And they're at a height that nothing should be staying there unless it's, it's the same density as water. Anyway, the stuff comes through and it overflows this into this, which was decided by the size of our columns on our house. They're like 33 inches by 31 or 32. Now, the bucket is underneath of this. So, originally, when I designed the thing, I was going to overflow it, have it go down into the bucket, and the water level, it would just go right into the rock and into the ground down below. Or if it wasn't leaving fast enough, the water level in this last fourth chamber would rise, and that gives you hydraulic pressure to push it into the ground. And a later revision was not on this drawing. This drawing was the one that we designed it with and pretty much built it to. The dimensions are accurate. But there's additions, like the air ports over here. And above the bucket, we put, from the bucket rather, up to the, to about a ½ inch below this wall, we put an 8-inch ABS pipe. And what that does is it lets the water go in here, which by that time is pretty pure, and it builds up the hydrostatic head to push it into the ground. But that's like having a fifth chamber. It's like one more processing separation. And if you had a septic tank, the normal holding tank type that you see all over the Philippines, you got a digester on one end that's about 75% of your tank, or maybe a little less. And you got a second one over here. First one's got a floor, second one's got a dirt bottom. Well, this is the equivalent of the second one to us, except that we've separated it by the two kinds of bacteria. Over here, the lid for the tank has got glass block, 4-inch thick, 8x8 glass blocks in this here, and that puts UV light into that digester, which kills off a lot of stuff. Now, we're not putting this buried underground. Our septic tank's going to be about 6 or 8 inches above the ground. And like all Filipinos, my wife wants a bunch of toilets through this lid and an actual wall or building or something around it, so it can be a public restroom in case somebody comes to visit her house. She doesn't want to see how lazy but not shameless we do our housekeeping. I can't imagine that we could make a mess out of this house. It's 29 rooms. To be sure, we can keep some rooms that people can see that aren't just, jumbled up. I mean, as long as I can carry it outside and set fire to it, it's not going to get full of junk. Anyway, for 62 to freedom, I see a potential problem that you won't be able to pump out a septic tank 20 feet below the road. One, the suction on the pump truck probably won't be able to establish suction to pull it out. You need something like a mud hog to push it out. And that kind of stuff's just not available. If you could somehow drive down onto the beach and not hang the truck, and get it up to your back fence, you might have a chance. But as far as pumping out a septic tank 20 feet below the road, which is also like a minimum of 5 feet in the ground, and like this one here is 11 feet into the ground. So it's a really tall septic tank. Anyway, I just thought there might be a problem, and I might do a video for the people whose septic tank is just a holding tank. Now, if you have a two-sided section, you've got a trap door in the top of this one for sure, and probably one in both sections. And if you've got a dirt floor in there, there's nothing to say you can't come in and put some 3/4 inch stone in the bottom, like 8 inches of it. Set you a 6 inch or 8 inch PVC pipe, come up to the height that you want your fluid retained at, and then you've turned a 2-chamber into a 3-chamber. Just pour a floor over top of that gravel with plastic so the cement doesn't go into the gravel. But you can you can modify a 2-chamber holding tank into a 2-digester septic tank. Not that hard to do, at least not on the construction side. You might have to get some younger employees that are willing to go down into a septic tank, but they go in there to clean them out. If 62 to Freedom has to get his cleaned out, he's going to have to hire people with buckets and carry that mess up to the road and dump it into something. I wouldn't want to do that. Not if I could avoid it. Not if I could have a plan ahead of time. I'm not saying this is the only way to build a septic tank. It's just a compact arrangement, with a fairly small foot and deep footprint. And the depth is because I want to be able to push the water from that gravel that's in a hole about almost twice the area of the floor in here to out to where the dirt was dug. I want to be able to shove that water into the ground, but I want it clean before I put it in the ground, because people have wells and stuff, and you don't want that contamination to get into drinking water. Okay. Yeah, it's another of my crappy, unedited, poorly presented videos. And I'm hoping to get 9, maybe even 10 viewers. And as you can see, if you've ever looked at our channel, that's a lot. But I think it's a good subject. Oh, this tank was built with slip forms. Well, these rectangles in here is the slip forms, but that's another project that's on the same page. I think that's the dirty kitchen. That is the dirty kitchen. Couldn't tell you why it's there. But as far as slip forms go, there are older videos. I know that's a terrible thing to say. Nobody ever watches a video once it gets 3 months old. I'm the only guy who goes back and watches somebody else's early videos. But this is dimensions for how to build these slip forms with zero waste of the materials. And all the bolt holes are interchangeable. But there's videos on how to make the kind of slip forms we're using. I stole the idea for slip forms from Texas Filipino. I'd seen them used on grain elevators and stuff before, but not for buildings. No reason why he couldn't, and he does. He built his whole house that way. he did kind of traditional slip forms on his first floor, and on his second floor, he's modified it to standing up the plywood and then putting the backer pieces on it, and nothing is actually attached to anything except the through bolts. It goes up really quick that way. And the alternative is the way we do it. We have 7 foot, 8 foot, and 4 foot forms, plus the corner form. And you see there's a particular kind of a construction on this corner and a different construction on the other corner. But what we do is when we design a dirty kitchen, for instance, we just set up the forms on the drawing here and see what we can make that's close to the square footage or square meters we wanted for the building. And that's what we do. And that's what this one over here is. That's probably why it's on this drawing. It's because the forms, there was a set of forms on this drawing for the septic tank, and there was a lot of space to write on. The drawing wasn't big, so it would load and update fast. So that's why we have the dirty kitchen stuck into the middle of our septic tank drawing. And it's probably been broke out as a separate drawing. I'm sure it has. Okay. Y'all pray for the poor people with COVID, and that they'll get the paperwork down to only needing a visa for the Philippines. Maybe we can get back someday. We're hibernating in the U.S. in the meantime. Okay. Bye.